Hello everyone, welcome to our channel. Let's learn together. In this video, I am going to talk about the Newton Raphson method. I'll explain the Newton Raphson method with an example. So what is the Newton Raphson method? So Newton Raphson method is one of the root finding techniques, same like the bisection method, the regular falsy method, etc. So first, this method is also called as the method of tangents. And first, let me explain you what is Newton Raphson method. So based on it is completely based on the initial approximations. Let's consider f of a into f of b is less than 0. Then modulus of f of a and f of b are they have to be calculated and then compared. So after calculating f of a and f of b, suppose if f of a is less than, modulus of f of a is less than modulus of f of b, then we have to take x equals to a as the initial approximation. Okay. Again, if modulus of f of a is greater than modulus of f of b, or modulus of f of b is less than modulus of f of b, then we have to take x equals to b as the initial approximation. So as I have said, this is completely based on the initial approximations. We have to consider this. Okay. Now consider the initial approximation as x0 and x1 is the actual root. Therefore, f of x1 is equals to 0 will be our algebraic equation where we have to find the actual root, that is x1. Okay, now we can write f of x1 as f of x0 plus x1 minus x0, right? Which is equals to x1, right? So now we'll be taking x1 minus x0 as the length of the interval h. Then we can write f of x0 plus h equals to 0. And now if we apply the Taylor series at the point x0 for this, then we'll be getting the Newton Raphson formula as xn plus 1 is equals to xn minus f of xn by f dash of xn. Okay. So using this Newton Raphson formula, we'll be finding out the approximations and also the actual root. So we have to repeat this process. This process is same as that of bisection method and all. Only the difference is we have to use this formula while calculating the approximations. Okay. And as we all know that we have to calculate minimum 2 approximations such that the successive approximations are approximately equal, and then we'll be finding the actual root. So now I'll explain the Newton Raphson method using an example. Okay. So let's start with the example, that is find the root of x power 4 minus x minus n equals 9 is equals to 0 by Newton Raphson method. I have written what are the conditions required and the formula of Newton Raphson method here. Whatever I have explained earlier, I have written here in a simpler manner. Like if modulus of f of a is less than modulus of f of b, then x equals to a is our initial approximation. And if modulus of f of b is less than modulus of f of a, or modulus of f of a is greater than modulus of f of b, then x equals to b is our initial approximation. And this is the Newton Raphson method formula. So now let's start with our solution. Okay. Now this is our f of x, right? Let's calculate f dash of x first. As per the formula, we have to also calculate f dash of x, right? So calculate f dash of x. That is, f dash of x is nothing but the differentiation. X power 4 differentiation is 4x cube minus x differentiation is 1 and the constant differentiation is 0. So this is our f dash of x. Okay. Now we have to calculate f of a, f of b and so on, right? So let's start with x equals to 0. Okay. Let x equals to 0. Then f of a. F of a is nothing but f of 0, right? Substitute here in this equation. That is f of 0 is equals to 0 power 4 minus 0 minus 9, which is equals to minus 9, and this is less than 0. Now calculate x equals to 1, that is f of 1. Substitute x equals to 1 in this equation. That is 1 power 4 minus 1 minus 9. Again minus 9, which is less than 0. Now what we have to check? F of a into f of b should be less than 0, right? F of a into f of b should be less than 0. Now if we take f of 0 and f of 1, f of 0 is negative and again f of b value is also negative. Minus into minus is plus, which is greater than 0. We are not satisfying this condition. Hence, we will go for x equals to 2. That is, calculate f of 2. Substitute 2 in this equation. You will get 2 power 4 minus 2 minus 9, which is equals to 5, which is greater than 0. Now check f of 1 into f of 2 is obviously less than 0. F of 1 is negative. F of 2 is positive. Negative into positive is less than 0. Hence, the condition is satisfied. Hence, the root lies in these both values. That is 1, 2. Okay. Now, what you have to do? We have to find f of a and f of b, right? Now, calculate f of a and f of b. That is f of modulus of f of 1, which is equals to, that is, substitute modulus of f of 1 is nothing but what? Which means f of 1 value is minus 9, right? Modulus of minus 9 will be plus 9. Okay. Now, again calculate modulus of f of 2. Modulus of f of 2. F of 2 is 5. That is modulus of 5, which is equals to 5. Now we have calculated f of 1 value and f of 2 value. Now what we have to check? These conditions we have to check. Okay. Now if we see, modulus of f of 1 is greater than modulus of f of 2. That means f of a is greater than f of b. That means we have to take x equals to b as our initial approximation. Therefore, our initial approximation, that is x naught, will be equal to 2. Okay. Now, by the Newton Raphson method formula, what you have to do? This is the formula. Xn plus 1 equals to xn minus f of xn by f dash of xn, right? Now, xn plus 1 equals to xn minus, what is f of xn? F of xn we are taking as this one, right? You just have to add xn. Xn power 4 minus xn minus 9 divided by, what is f dash of xn? Here we calculated, right? That is 4xn cube minus 1. Now calculate this whole thing. What you will be getting? Xn. Calculate this whole thing. Cross multiply, right? Xn into 4xn cube minus 1 minus xn power 4 minus xn minus 9 whole divided by 4xn cube minus 1. Calculate this whole thing. Okay. Now, what you will get, I will just write here. That is xn plus 1 will be, calculating this whole, 3xn power 4 plus 9 divided by 4xn cube minus 1. Okay. Just remember this now. Okay, fine. So we have calculated the xn plus 1 from the above steps, right? Just remember this. Now what you have to do? Put n equals to 0 here in this equation. That is x 0 plus 1. That is x1. This is our first approximation. Okay. First approximation. So x1. What you have to do? You have to put n equals to 0, right? 3xn. 3x naught power 4 plus 9 divided by 4x naught cube minus 1. We have calculated x naught, right? That is our initial approximation and we got x naught as 2. Just substitute here in place of x naught. 3 into 2 power 4 plus 9 divided by 4 into 2 cube minus 1. Then you will be getting x1 equals to 1.83. Okay, remember this x1 value. Now we have to calculate the second approximation, right? Now what you have to do, put n equals to 1. Then substitute here in this equation x1 plus 1, which is equals to x1 plus 1 equals to x2, which is equals to 3xn power 4. 3n is 1. 3x1 power 4 plus 9 divided by 4 xn cube. N means 1. x1 cube minus 1. Okay. Therefore, x2 will be 3. x1 value is 1.83, right? Whole power 4 plus 9 divided by 4 into x1 cube. x1 is 1.83 minus 1. Okay. Therefore, x2 value will be what? x2 value will be 1.81. Okay. Now, check whether x1 value and x2 value are approximately equal. Like up to single digits, they are approximately equal. So, we have to go for another approximation now. Okay. We'll go for the third approximation. So, I have erased the first approximation and now I am going for the third approximation. Okay. Third approximation, what you have to do? Take n equals to 2 and substitute n equals to 2 in this equation. Therefore, you will get 2 plus 1 is x3. Third approximation. Substitute again 3 into xn means n is 2. 2 whole power 4 plus 9 divided by 4 x2 cube plus minus 1. So, again our x2 value is 1.81. Okay, I'm just erasing this. x2 value is 1.81. Now substitute x3 equals to 3 into 1.81 power 4 plus 9 divided by 4 into 1.81 whole cube minus 1. Now calculate the whole value. You will be getting x3 as 1.813. We know that x2 value is 1.81. Compare these both values. They are approximately equal. x2 is approximately equal to x3. Therefore, we can stop the process of finding the approximation. Therefore, the root is 1.813. So, this is our real root for this equation using the Newton Raphson method. Thanks for watching. Do like, share and subscribe for more videos, and do check the playlist of mathematical transformation techniques course for all the videos I have uploaded there. Thank you. Bye.